Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and this is Hot Work. All right, I have a collage of projects that have been backing up since the last couple weeks when I've been doing the brazing T-nut slot scrapers, and this is time to get going on them. Hot Work. I remember back in the yards, we used to always have to get the Hot Work chit or certification for a compartment or space on a naval vessel or building, and the personnel responsible for that job would come in and inspect the space itself for explosives, flammables, and so on, and then would write up the chit, and then you were okay to have your hot work in there. And when you're working by yourself, there's a couple tips. Get the acetone and those kind of things away from the welding after you have things prepped up. If you have to use it, make sure there's no rags, and hang on or hang around at least a half an hour after you've done your job, just to make sure that there's nothing smoldering that you didn't notice when you stopped or during the process. All right, I have a collage of projects. This is a heat exchanger, brand new. I've already kind of started on it. I sweated off this fitting here, which was put on in this direction. This is on a new engine that's being installed, and the old engine, it was taken out and it was sold and it was on its way out before this one came in, and now all of a sudden this is a panic because of course this needs to be taken care of and rerouted. There's an exhaust type of piece that comes in here, and they need to have this turned around, so we're going to install that elbow in that direction. We're going to use Stay Sil 15 from Harris. This is a 15% silver brazing rod, and it's known for, or it's designed for irregular surfaces. It can handle some gaps and stuff like that. Also heat changes and also vibration. So it's it's a good rod to use on a project like this, and that's what we're going to use for that. Our next project that we have in line here is a cast iron exhaust manifold. It may actually mount like this, I'm not sure, but regardless, I'm going to prep, and we're going to braze that with low fuming brazing rod, and we're going to use a high heat flux. I'll groove that out, and I'm probably going to make a backup strip so I can put a couple bolts in there to hold that while we heat it up, braze it up, and then let it cool down, and it should hold that pretty close. He may still have to face off that face of the flange. The next project is a strut from an 80s something vintage airplane, and there's a little tiny ear here, and this bolt has, at the hole for the bolt, has got an excess clearance, and it causes the thing to chatter a little bit. This arm, that linkage that goes with this, is like a pilot autopilot on a boat, and so we're going to go ahead and we're just going to fill that hole, and we're going to ream it out tighter and get that set up for him. We're going to use ER70 TIG rod for that. Our next project here is also going to be a TIG welding project, and this is a racing valve cover. It is all welded. This is all a jigged up and welded valve cover. It's pretty cool. He had a fitting in here, but he had a nut and a washer type of thing in here, and he's afraid of that getting lodged down in the engine, so he brought me a weld in, and I'm going to open up this hole, clean up this face here, and we're going to weld that on. And we're going to use 4043 TIG rod for that. And our last job, which will probably take a few days past us doing the video here, there's numerous breakouts and all kinds of pecker tracks from prior owners, including knocking out the baffles that are supposed to be in this side of the cases here. There's some broken off ears and ports. And I believe there's even a web that's down inside here. And we're going to be using 4643 rod, which is excellent on building up and maintaining the integrity and remachining. I really like that rod for that. and that'll be a TIG job as well. These are World War II vintage Indian motorcycle cases. Pretty cool. All right, let's go ahead and start off on our cooler. Okay, we have already scribed a line right around here, kind of showing where this is going to sit, and we've got an idea that's going to go right there. And we want to go ahead and take some, this is just Stay Silver Flux, and we're going to cover this area right here. We're rubbing it so that it actually forces the material to touch and wet that surface all the way around. It's really important because it actually does a cleaning, etching type action on that surface there, and that's what makes the silver solder want to go in there and join that. The same thing around this lip right here. Okay, and then we're going to set this on here in position there, and we're going to take our other finger there and we're just kind of wiping it. The copper dissipates a lot of heat, and the bronze is heavier piece, so it's kind of the combination of saturating the heat enough to melt the silver solder at that joint and to get it to flow in there and join the two pieces together. Oh, it doesn't happen. I mean, you can't put the torch there and start melting and stick it in there. You got to wait for everything to get up to temperature. Now I do bring the tip of that cone, that inner cone of the flame, to a sharp point, and that's how I use to control my flame. Now if I want it down lower, I would lower down my acetylene and then tune my oxygen into it for less heat. Now I can lengthen that just slightly if I want to for a little less heat, but I'd rather keep it like a pencil, sharp, and then I can control it where I want to after that. Right now, I work back and then in and out to control the heat as well. The very first thing before you even try to add anything is to go ahead and saturate the part. And at the same time, you try to get your gloves on. All right. I'm going to try to use up some of my short pieces that I have today. That's why I got the vice grips out, and I'm kind of holding them that way. Just trying to be a little cost effective on my materials, that's all. You see the solder, the flux starts sweating. It's getting close. You can see the change of the color of the materials. Now I'll take a dab in here just to see if it's going to start taking. And it's starting to take. We're real close to temperature now. You can actually see it get stuck underneath there, that's what you want. And you can tell when both pieces are really the right temperature. If some of it's out on the surface, you're not really concerned on that. You're really looking at that split line and what that's doing. Okay, that looks pretty good to me. Okay, what you really like to see is looking inside and seeing the silver solder wicking to the inside surface. That's great. You know, it went all the way underneath the lip and all the way through and through. Okay, we transfer punched a plate and drilled it out, and I just went and got my 9/16 wrench here. Okay. With that bolted to there, we're going to be keeping our flange as flat as possible. And here's a nice piece of hot roll, and we're just going to leave it at that. Alright, now we're going to want to set this thing up so that we can grind and prep this groove out right here. So I think I'm going to hang it off of here. We're going to get our disc grinder, and we're going to come in here and grind it. After I do that, then we'll take the rotary burr and we'll be cleaning the prep out of the grinding grit from the wheel. It's important to get all of the grit from the grinding wheel out of your welding area or brazing area. Okay, just before we start grinding, there is one thing that I want to do. Come and follow the crack as close as we possibly can. And the last little bit that I actually see of that crack is right there. What I want to do is I want to drill a hole so that the crack does not continue on past the hole or the diameter. We are right down here. I mean, you are so close to that outside that we're going to be lucky if this doesn't break out to the face of that flange, and that's what we're trying to keep it from doing. So we're going to drill a hole right there, and then we're going to drill one over at the other end. Let's get this one here while we're in that position. Okay, and don't be afraid of the size of the hole. You're going to braze it up. It's going to be part of the braze. In fact, we're going to be grooving out this till we get down in there. And we're just hoping that we got down here and we caught this in time before it had a chance to jump across that hole. All right, and it's pretty thin. It's less than 1/8 of an inch wall thickness on this what's left of this manifold here. All right, let's put it out of here so we can get to the other side. And not cool, it can stay like that, but we're gonna grab one of our angles there, just to kind of put it there. There we go. Okay. Believe it or not, the flashlight actually really does, the LED really shows up on the crack there. Nice job on blasting the area for me. Of course, it's going to be toasted back beyond this here. Just a little bit more past where I think it is. All right, and we'll go ahead and we'll drill this one out. Okay. Glad I didn't have to go get the drill chuck that was on the other side. All right, let's go ahead and take our grinder and grind that now. Okay, one of my Milwaukee's got a Charger Plus. It's a Norton. I believe it's a Norton. And it does pretty good. But we're going to be just starting a groove in here. So see here. Okay, there's a little area right there. We're just going to get that with our rotary burr. We're going to continue on. See how this is really shallow. If we don't get down in there, you're not going to have great luck. In making it last. Okay. Now that we've got that opened up, now we want to go ahead and take our rotary burr. We're just going to freshen that surface all the way around here, because when the brazing flux goes over the edge, this will roll over and it'll really catch the whole edge of it. Not really trying to take anything off except for that sandblast surface. Okay, I think we're pretty well prepped. Let's get it set up to where we can reach that whole thing and braze it in one shot. Okay, I've got this clamp so it's holding it up in this position here. I'm going to be using anti-borax brazing flux. This is number 2. This is white. My all-time favorite is actually Peterson's flux, and it's kind of a gray color. It's the same thing, but it's getting pretty old. It's getting pretty chunky, and I've been getting used to this. You know, it's like I think it's psychological more than anything else. But I just want to prove that it's to myself that it's an okay material as well. All right, we're gonna heat it up first, and just bring up the temperature on it slowly. And here again, I'm just bringing in my flame to where I just sharpen that cone. Then I know I'm not going to soot it up or anything else like that. Active in the temperature range of 1400 to 2000. And we know that about 15 or 1600 degrees Fahrenheit is about where we're at when we're actually brazing this. Put that rod down. That's the thing. Don't get impatient. You want to actually heat this whole thing up here. You don't want one part of it really hot. If the wood stove was really going good, I could put this on top of the wood stove and it would have preheated the whole thing up to at least 300-400 degrees. Okay, we got our fan going in the back corner there, and we have the door cracked so we don't breathe the fumes of the flux. Not a good idea to do that. Alright, now we're going to start focusing our heat in this general area. We're going to go vertical, and then we'll come over here and then we'll roll that way. And we'll meet up somewhere around that bolt right there. But I think I want to join up this troublesome area over here. Doesn't look like the crack continued over to that flange lip there. Some people like flux already on the rod. I don't. I like to add it myself. Okay, now we're just going to focus in where we're going to want to start. right in that hole. We want to flood that hole. We want to see that brazed material on the inside of that hole when we're all done. Okay, so we get some flux started here. Okay. It does help to have the shield on a little bit. Okay, now I'm going to come up the other side. I'm going to rotate this around, see if you can see that. I'll get a close-up picture afterwards. That one came a little short. I like that. This flux washes off with hot water as well. Okay. We're going to go ahead and put the blanket over the top of this. Cool slowly right there without messing with it. Okay, got this end of ice with the ground strap connected to the vise. We got the foot pedal down here. We're about 100 amps, and we got our tick rod here. And we're going to just go ahead and we're going to come in and we're going to try to seal that hole. We're just going to rosette weld in that hole. Okay, we're going to let that cool and then we're going to come in from the other side. Okay, now we're on the back side. Now what I'm going to do is I'm going to get down here close enough to where I can really see it. Get set up here, we're going to put on the pedal, and I need to wash that side in so we got 100% penetration, so I can't just float this on like I cap the other end. I need to actually make sure that I'm joining or washing in the walls all the way around that before I add material in there. I have enough added on there. I think I need to find a new wire brush. A little bit low on this side here. Okay, I'm sure we got enough on there now. Okay, we're setting up to weld that fitting into the end of the valve cover. And you can see this is ultra lightweight valve cover, all machined. I even looked at the side there, and you know, that's machined, that flange around the outside edge and weld penetration. I know it's, you know, all that weld was on the outside, but that's some thin gauge stuff. Okay, there's the hole we got to dress up. That's the beautiest, right? All right, and you can see it's brought nice and clean. But we're gonna take the rotary burr and we're gonna clean that out, and we're gonna be throwing some Alumatap in there on our burr, and that's what we keep our burr. And then we'll acetone wash the area we're gonna weld to, and then we're gonna let it fly. Okay, we got a little color ring there where whatever flange was on the other fitting that used to sandwich in there. I'm going to take the rotary burr, and I like using a little Alumatap. Kind of just keeps it from balling up. And we're just going to take and gently work this. We put it in upside down. We don't care if it's open down here on the other side of the table. The stuff can go out there. Blowing it back into the, you know, this the air goes forward on this thing, so most of it blows in there, but some of it blows out here and blows back. But that stays pretty clean with the Lumitap on there. Keeps it from clogging up. All right, we're gonna check this. We had to go about 1/8 of an inch. Some people think that you're just gonna put it in a machine and machine that out, but all I need is a hand job. All right, now we're gonna hit the face, deburr the inside, and then wash it down with acetone. Should we get a picture of that inside? I think so. Okay, blow off our area, acetone wash it, put away our stuff, and then fire off our welder. Okay, I got this brass round and this little plate here that's going to come up and underneath, and what I want it to do is support around this edge here, and the plug's going to snap in there, but I want to support that material all the way around, and the foot of this plant will just go on the snout of that, and it'll give me plenty of room all the way around that to weld. Let's stick this up and underneath here. It did fit. Oh, maybe I had it the other way around. Yeah, that's what I did. Okay. Then we put this underneath it. Okay. That way heat and everything else, I'm not going to have any motion or movement on that, and the thickness of that part in there is going to draw enough heat away. I don't want to melt. This is beer can. I don't like. I really don't like welding on it. But like I said, sometimes if you do a job and you do it well, you're going to get something else to test your skills there. And I welded his radiator on his Corvette, and now I got this. Okay. I'm not running any big cups or anything else like that. Just in case I need it, I might need one of Jody's take fingers just to sit here and prop like that, so it's not hot or it doesn't get hot. But I hope it's not tainted. Set on here. Wardrobe malfunction. Let's see. Okay, we're going to take the first two pieces of the Indian motorcycle here. Then I have to do a pretty tricky build-up. This is all missing on this end right here. You can see the sample, this piece here was given to me to create the same thing here. There's a port, threaded port this way, and a threaded port that way, and that's a channel that goes down to this area. From the bottom of that thread to the top up here is 3/4 of an inch, and there's 3/4 of an inch. So I have to build up that material to my fingernail there, that far, the end of the measure there. All right, that's quite a bit of material. Now, this is the start of the port, threaded port this way. Oh, how are you going to fill this all in and build that up, tap that and tap this, and know that you're in line with that hole? All right, well, that's what this is all about, and I'm going to share with you how I'm going to go about building this material up and maintaining that bore on that hole. Now, this has been tapped again going in this direction here, which doesn't need to be. The tap of the plug only needs to go into the depth of the 90 there. That passage actually has no threads down in there, but somebody, when this got knocked off, they put threads in there to plug it up completely instead of having to cross connect two. Okay, and I don't know if that's a vent or what it actually is. I'm not trying to get educated that way. I just need to make the material match and the holes in the threads. They did give me two samples of the threads. This fitting has that thread on it, and then this plug has the thread that they want in here. So I can duplicate those threads here. Not necessarily that those two pieces go in there, but that is the matching threads that they want. Okay, the very first thing I'm going to do is take the rotary burr and I'm going to clean that material. And this whole surface right here has been oxidizing slightly, and he just got these, dropped these off, and these have all been sandblasted. Boy, it really looks like some nice aluminum in these parts. That's cool. Okay. Now, I'm not worried about referencing this hole and stuff because I have a hole pattern here and I have a hole pattern on the other, and I'll be able to make a template and come and pick up this hole here, so I'm not really worried about that. But I was worried about all the cleanliness there. Alright, now we're going to get a set up in the vise, and we're going to go ahead and we're going to take a round steel rod, 3/8 diameter. We're going to stick it down into the hole here. Alright, now I know that this end of the rod is bent, and but this end from here on is straight. Oh, I'm going to start out. It's slightly loose. It's a 3/8 rod, and it also goes through the other one with the tapped hole and everything, so I know that I'm going to be keeping at least the diameter I need to. Now I'm going to weld that aluminum all around that steel and then pull the steel out and have that hole. I'll build it up to a certain distance out, and then with the rod out, I'll be able to put a sealing bead up at the top where the threads are going to be the most important for that plug coming in on the end. And then I'll be able to reach in and grab that thread and do the side port all machine wise. Alright, I got you setting in as close as I can in different directions there. I have to be the most comfortable here, and what I'm trying for is this side here, and I'm gonna it's the biggest side here, so I'm gonna go ahead and I'm gonna start on. It's gonna take a while to build up some heat here, and then I'm gonna be washing it down to the steel rod. I gotta go put the helmet on my desk there because the batteries are out or dead, and giving me an arc out there. Okay, there we go. It's still starting to get a little warm. And see, you can just pull that, slightly roll it, keep it free. All right. When you start seeing any impurities coming up to the surface, you want to take and wire brush those away. Keep your aluminum clean. If it looks too bad, then take the rotary burr and you want to knock that loose. But you do have to keep it hot and work it and let it roll into the steel. And we're just working it on the side right now because we're working on this heavy end here. Okay, now I think we're going to stand it up so that I can work it vertically there, and I know that this rod is going to be a little more stable. I'm going to grab a pair of channel locks, vice grips here, so I can grab it on the end. There we go. See, you can always move it. You just want to make sure it stays free. The aluminum won't join it as long as you don't make the steel molten. The steel melts at a much higher temperature than the aluminum does. Alright, I thought I'd give you a shot up here. I got the thing set up on the bench now, so I'm going to start going around it in this position here. And you can see that's that top section there that I was working in close to it. Okay, see how that comes in? I'm in farther than the bore threads there that were there. Pretty cool. Okay. All right, I think we're all set. Here we go. We're not all set. You need to have a ground. And there's our first pass around. And there we go. We're on our way building our build-up. We'll do some cleanup, a little bit between each pass, and don't get ahead of yourself. Gravity helps a little bit, so I roll it with the pin in line. Alright, it looks like we got a little bit of work ahead of us. We got to set up the plasma cutter and cut out some baffles and do some other things, but we're going to work on this wall build up here. Alright, that's kind of a gist of the hot work that we have going on in the shop today. Kind of the mix that we normally get. All right, until next time, get her done.